When it comes to quantum computing, most people are understandably focused on the threat it poses to encryption. If that's all you've heard about quantum computing, though, you're only getting the 20-watt version of a very powerful engine. Quantum's ability to crack encryption is impressive, yes, but it's really just a warm-up act for what this transformative technology can accomplish. Now imagine if we could simulate the behavior of molecules down to their quantum level. With this capability alone, we could develop room-temperature superconductors, design ultra-efficient solar cells, and create entirely new materials with properties we tailor ourselves. These are just a few examples of what's possible when we harness the power of quantum computing to solve problems that were previously thought to be impossible. So join us as we look beyond encryption and explore 5 industries that quantum computing will revolutionize. The first industry to feel quantum's impact will be the development of new materials. Material scientists study the properties of matter and how they relate to the structure of atoms and molecules. But the equations that govern these interactions are so complex that simulating them is currently beyond the capabilities of even the most advanced classical computers. Quantum computers, however, thrive on complexity. They use the principles of quantum mechanics to represent and process information, which allows them to tackle problems that would take a classical computer millions or even billions of years to solve. By simulating the behavior of molecules at the atomic level, material scientists will be able to design new materials with unprecedented precision. This could lead to the development of materials with tailored properties for specific applications, such as lightweight, yet super-strong alloys for aerospace or highly efficient solar cells that convert sunlight into electricity with minimal energy loss. In fact, a recent study by IBM researchers has already demonstrated the potential of quantum computing in this area. Using a quantum computer, they simulated the behavior of a small molecule, azulin, which exhibits superconductivity at extremely low temperatures. The simulation was able to accurately predict the properties of the material, which was later verified through laboratory experiments. This is just a glimpse of what's to come. As quantum computers become more powerful, they will enable us to understand and manipulate materials at an atomic level, leading to a whole new world of possibilities in material science. Another field that stands to benefit immensely from quantum computing is drug discovery. Developing new drugs is a lengthy and expensive process that often takes many years and billions of dollars. One of the biggest challenges in this process is understanding how a drug will interact with the body's complex biological processes. Again, we encounter a problem that's too complex for traditional computers. But quantum computers can simulate these interactions with greater accuracy, allowing researchers to identify potential drug candidates much faster. By modeling the interaction between drugs and their targets, such as proteins or enzymes, quantum computers can predict how well a drug will work before it's even tested in a lab. This could significantly reduce the time and cost associated with drug development, while also increasing the likelihood of success. Imagine a future where diseases like cancer and Alzheimer's were treated with drugs that are designed to interact with the body at a molecular level, causing no side effects and offering a cure, where today there is only palliative care. That future is closer than ever thanks to quantum computing. Optimizing the complex systems that drive our modern world will be another area where quantum computing will shine. Supply chains, logistics, and financial markets all rely on complex networks that are difficult to manage effectively. Quantum computers, however, can quickly solve optimization problems that would take classical computers hours or even days to figure out. This means that companies will be able to optimize their supply chains, improve efficiency, and reduce waste across the board. For example, quantum computing can help optimize the scheduling of flights, reducing delays and improving efficiency in the airline industry. It can also help optimize the transportation of goods, reducing costs and delivery times in the logistics industry. And in finance, quantum computers can help optimize investment portfolios, reducing risk and maximizing returns. The applications for optimization are endless, and the potential for improvement is huge. But it's not just about efficiency gains. Quantum computing can also help us solve some of the toughest problems in science and engineering. Take traffic flow, for instance. Quantum computers can help us model and optimize traffic patterns in real time, reducing congestion and travel time in our cities. They can also help us manage water resources more efficiently, allocate energy more effectively, and even protect the environment from pollution. We're just beginning to scratch the surface of what's possible, and the potential for good is enormous. The fifth and perhaps most transformative industry that quantum computing will revolutionize is artificial intelligence. Machine learning algorithms rely on identifying patterns in data, which is essentially a search problem. Quantum computers are exponentially faster at searching large datasets than classical computers, meaning that they can help develop machine learning algorithms that are far more accurate and efficient. For example, quantum computing can help improve computer vision, which is the ability of machines to see and interpret images. This could lead to better medical imaging, autonomous vehicles, and robots that can navigate complex environments. Natural language processing, which is the ability of machines to understand and generate human language, could also be greatly improved by quantum computing. This could lead to better chatbots, virtual assistants, and machine translation. But perhaps the most exciting prospect is the possibility of creating true artificial general intelligence, or a GI, which is intelligence that matches or exceeds that of humans. Some experts believe that quantum computing will be a key enabler of AGI because of its ability to perform calculations and simulations that are impossible for classical computers. While others remain skeptical, it's clear that quantum computing will have a major impact on the future of AI, whether or not it leads to the creation of Skynet. While the potential applications of quantum computing are vast, we must also acknowledge the challenges that lie ahead. One of the biggest hurdles is the difficulty of maintaining the delicate quantum states of qubits, the basic unit of computation in a quantum computer. Qubits are extremely sensitive to noise and errors, which can cause them to lose their quantum properties. Another challenge is the lack of a universal quantum programming language, making it difficult for developers to write and execute code. Despite these challenges, progress is being made. Researchers are developing new methods to control and correct errors in quantum computers, and several companies are working on developing user-friendly interfaces for quantum programming. As we continue to push the boundaries of quantum computing, it's important to consider the broader implications of this technology. One concern is that quantum computers could pose a threat to national security by breaking encryption algorithms that protect sensitive data. Another concern is that quantum computing could exacerbate the existing wealth gap by giving an unfair advantage to those who have access to this technology. To mitigate these risks, it's important that we develop proactive ethical frameworks for the development and use of quantum computing. This includes ensuring that quantum technology is accessible to everyone regardless of their background or resources. It also means being aware of the potential impact of quantum computing on society, and taking steps to ensure that it benefits everyone. So what can you do to prepare for the quantum revolution? The first step is to educate yourself about quantum computing and its potential applications. There are numerous online courses and resources available that can help you develop a basic understanding of this technology. You can also stay up to date with the latest developments in quantum computing by following industry leaders and attending conferences and events. Finally, you can support organizations that are working to develop ethical and responsible quantum computing practices. By investing in the future of quantum computing, we can ensure that this technology is used for the benefit of humanity as a whole. It's easy to get caught up in the hype surrounding quantum computing and imagine a future where quantum computers are commonplace and their applications seem limitless. However, it's also important to be aware of the challenges and potential risks of this technology. By staying informed and engaging with the broader community, we can ensure that quantum computing is developed and used responsibly, paving the way for a future where everyone can benefit from this incredible technology. Don't wait until the quantum revolution is in full swing to get involved. Start today by educating yourself, staying informed, and supporting organizations that are shaping the future of quantum computing. Together, we can ensure that quantum computing is used to solve the world's biggest problems and create a better future for everyone.